Just a reminder for those who haven't already, there is a document attached to this meeting. Please do sign in. That the YouTube stream is up and running. The next item is new faces. I do see we have a few new faces. Rob, would you like to introduce yourself?
Yeah, I'm a developer at Google, and I'm working on the Cloud Run, Cloud Functions, and App Engine products. Specifically, I'm focusing on some stuff with build packs. So that's why I joined this meeting.
Great. Nice to have you here. I'm Sambhav. You can call me Sam. I'm one of the maintainers on the build packs project. And yeah, I guess we can go around and introduce the rest of the people on this call.
I can introduce myself. I don't know if I've ever joined this meeting before. I've been in some other CNB working group meetings, but my name is Sophie. I'm a developer working at VMware. I currently am working on Paketo build packs, so an implementation of the cloud native build pack spec, and I'm a maintainer on the Paketo.NET Core build packs, our Ruby build packs, and our tooling, and most recently our stacks now. So thought I would join today. Say hey to everyone.
Okay, I think I can go next. I'm also working on VMware and the build packs team. This is my first meeting with the Paketo and build packs authors. Basically, I joined because I'm working on I just create some PR in the native image build pack just to try to add some support to compile Quarkus application with it. So I just joined to, meet new people and see if I can find some helps there. So yeah.
I guess I'll go next. I'm Gabe. I'm a developer at Bloomberg. I work with Sambhav and Aiden. I've been working internally on some build packs things, and this is also my first meeting here. So nice to meet you all.
Do you want all of us to introduce ourselves, Sam, or just the new faces?
I mean, it'll be nice for all the new faces to know you. So,
hi, I'm Aiden. I work with Sambhav and Gabe, although they might be at different places on your monitor. Yeah, write build packs internally on the team that maintain our internal stacks. End up using a lot of the Paketo stuff, so thank you very much for all that. And we modified to our own ends internally.
I think Forrest, you're the last one left. Oh, and Daniel's here as well.
Hi, I'm Forrest. I work on VMware on the Paketo build packs. Yeah, building out all your favorite Paketo build packs.
What is Paketo?
Paketo is an open source, vendor neutral cloud native build packs implementation project. So we implement build packs to the cloud native build pack specs.
Yeah, we as a project have 3 sort of suggested builders. There's the Google one, there's the Paketo one, and there's the Heroku one on pack. I mean, but it's nice to see people from both the sides here. It's the first time we have had someone from Google participate in one of these meetings. So it's really nice to have you here. Let's get started. Status updates. There were a couple of patch releases of libcnb that went out, mostly fixing a few bugs and enforcing the SBOM format with the actual things that people are writing. this is so that we catch it early on in libcnb and not later on in the life cycle when it actually errors out, so that people who are doing unit tests using libcnb know beforehand if they're doing something wrong. Thanks, Daniel, for both of those patches. And I think that's pretty much it. I know the implementation team is looking to cut a new patch release of lifecycle with a few bug fixes related to the new SBOM functionality, especially the restore logic when you have launch only layers. And I think that might be something we all want to look out for. So if you're using the new buildpack API and you're seeing some issues in the restore logic, there's a upstream lifecycle issue, which I think should be going out this week. I have linked it in the doc there. And I think that's it in terms of status updates for me. Daniel, do you have anything?
No, I think you summarized it pretty well. Oh, actually, probably the only thing, we still don't have the pack release out. I'm not sure how other people feel about that. I don't mind using the RC for testing, but I feel like it's probably gonna make it take a little while longer before people actually start using the SBOM stuff we've put into a lot of our build packs.
Yeah, I think the only thing stopping the actual release is this lifecycle patch. We're just hoping that that goes out and we can include that as the default lifecycle version in pack before we ship out a release.
Okay, that makes sense.
There's one more standing item, RFCs, but meanwhile, if you have any other items on the agenda that you'd like to add, please go ahead and do that. I am going to add libcnb 2.0 because it might be nice to discuss that with a wider audience.
Sambhav, is it worth just briefly outlining the RFC process and what RFCs are for?
Sure, yeah. Let me just pull up the screen and talk about what we do here in terms of RFC reviews. So all the new features that go into the build packs project must go through an RFC process. In this specific meeting, we look at RFCs that relate to features that may impact build pack authors. So anything tagged with the build pack author tag. Most recently, these are like some of the recent RFCs that do have impact on build pack authors. I think we've covered most of them in the last few meetings. There have been a few updates to the run image SBOM one, and there's a new RFC here to replace the positional arguments to the build binary in favor of environment variable ones. So maybe we can just talk about that briefly. I don't know how much I know the Paketo folks have been working a lot on the SBOM stuff, but for those of us who are new to the SBOM implementation in build packs, we recently merged in a bunch of things to allow build packs to output bill of materials in some standard formats. These include SPDX, CycloneDX, and SIFT. This is to ensure that build packs can create these bill of materials during the build time, as opposed to scanning it later from the output image, which may be less accurate than what you're creating if you know all the build time dependencies that are going into your image. So that RFC and implementation solved it for all the build pack layers, but we still don't have anything for the run image. So this RFC tries to solve it for the run image. It obviously comes with a few complexities on how to include this SBOM file in the run image and how it will be handled during rebase or during merge, or how you'll merge these SBOMs with the build pack ones. I think this specific RFC still leaves out the merging part, but tries to address putting the SBOM in a way that still works across rebases fairly quickly. The idea being that you add an SBOM file in a similar format to what the build packs now output, but in a location which is /CNB/SBOM, and it is attached to the run image. I think the main points of discussion on this RFC right now is how you'll attach this image, this SBOM to the image without with concerns like this will mutate the image, or like how will you identify the diff ID of the previous layers while attaching the SBOM, because it requires the run image SBOM to be, and the diff ID of that layer to be present as a label on the output image. So the main points of contention were like that this cannot now be done in a single Docker build, and you need a specialized tool or subcommand under pack to attach this SBOM and update the base image to reflect the specification. I think that's what we were discussing. But if anyone has any updates or any better ideas on how we can attach the run image SBOM, please leave comments on this RFC. Any questions, concerns?
I guess actually I have a quick question. I feel I haven't been able to join the working group meeting in a few weeks, and I know that this has been a discussion for a while, and I was just wondering if any like viable alternatives to what's been discussed in the RFC are becoming like front runners, because I haven't seen that much like written in the RFC or in the conversation about like what alternatives are being considered, if any.
I don't think we came up with any alternatives in the last working group meeting. Anthony, the author of this RFC, and Javier were planning on brainstorming and coming up with a few alternatives, but yesterday in the common working group meeting, we decided that this RFC can go in as long as it clearly defines what functionality pack would provide to ease the attachment of such SBOMs. And the other concern that a lot of people had is how this affects our general Docker files RFC, which is another important feature which allows for arbitrary image extensions, including installing arbitrary like apt packages or yum packages or whatever, system packages basically, and how this RFC would play in when you're trying to create SBOMs for this dynamically extended images. I think we decided to put this in as it is with the pack functionality, or at least no one had any oppositions to that in the last working group meeting. We are still waiting for votes, but Anthony was supposed to update the run image SBOM RFC with the pack utility commands, and once that's there, we were willing to like let that go for now to provide the complete SBOM functionality across the output image, and then figure out how to deal with the Docker files one next.
Cool, that's helpful. I'll keep an eye out for updates.
Any other questions on that, or should we move on to the last RFC? Okay, the other one is replace positional arguments with environment variables. I think the idea here is that the build binary currently gets these three variables as positional arguments, and we want to move that to environment variables so that it's easier for certain build packs to like read these values, and it's easier for us as a project to introduce new things here, which is backwards compatible. Because of the way positional arguments are provided, we can't introduce or add new things here without breaking the build binary. So as we've added more things, we've added more things to environment variables as opposed to this, as opposed to command line arguments. So I think this is just to make it consistent with the rest of the arguments we provide to the build binary. This still proposes that we keep the positional arguments for backwards compatibility, but I think the debating points are whether we should show some warnings or like silently deprecate it, which is just remove all traces of it from our documentation, but all build packs that use it can still use it. But that was it on this RFC. There are a few others that I still have as drafts, which I opened up yesterday, which are not yet tagged. But I think maybe some of the people here would be interested in it. One is this image history metadata RFC, which sort of makes it easy for build pack created images to be visualized by tools like Dive or on Docker Hub or like other container registries that try to list out the history key in the image config and print it out. So currently, if you take a build packs image and view it on Docker Hub or any of these other tools, they all just appear as blank values with no idea of what these layers actually contain. So this proposes adding some default values to make them like more friendly for such inspection tools. I don't think there are any breaking changes apart from this specific edition of adding a name key to the slice. So if you're using app slices, currently you can just specify the path globs. This proposes that we add a name key as well to uniquely identify the application slice and what it contains.
Would that potentially be a way to actually have a timestamp of when the image was created? It's like I understand why we squash those, but it's always like the first question I get from new people, and one of the biggest complaints is I can't see when my image was created.
So the history config does have a created at timestamp. I think one of the reasons why we don't, or we fix that to a specific point in time, is to allow for reproducibility. I've currently not added that here. But like any comments appreciated. If you think that's useful in favor of reproducibility, we can add that.
Not if it's going to impact reproducibility. I had for a moment briefly thought perhaps this would be something that wouldn't impact reproducibility, but if it does, then
yeah, the output digest would, like the output image digest would end up becoming different, even though the layers would be reused. The image digest would be different between different ones, which I don't think.
Yeah, that doesn't sound right. Okay, never mind then.
That's pretty much it from the RFCs front, unless someone has any other RFCs they would like to bring up.
What do you see, or do you see any that we should be targeting for libcnb work?
I think if this image history metadata comes in, I'm guessing like we have a new key here that we'll probably have to add. The other one that, although does not relate directly to libcnb but will fall under purview, is the whole utilities build pack stuff. So I think when we were doing release planning this week, we were planning out the build pack API 08. And currently that has these few RFCs in, which is like remove all shell specific logic, so removing profile D scripts and the dependency on a shell like bash on the lifecycle. So this is going to be coupled with that utilities build pack RFC that proposes we add a utility build pack that converts profile D scripts into execd executables. So I think that's probably going to come under our area, along with some of the other utility build packs that we've been talking about, especially around project descriptor.
Okay.
Which brings us to our next agenda item in case anyone has anything else on RFCs. Okay, I'm gonna take that as a no, and if Zoom cooperates with me, I will try to bring up our libcnb 2.0 document. So I just want to talk about V2 of libcnb again, since we have so many people here. And I know that both Google and Paketo use libcnb for a bunch of their build packs, but they also wrap libcnb and add a bunch of utilities around it. So we've noticed that there are like some common requirements that the base implementation should provide, which should allow it to be reused in the way that Paketo and Google currently do, which is like it's a non-opinionated API binding that you can wrap and add utilities to however you want. So that goal isn't changing in terms of the libcnb core functionality. I think there have been a few interface changes that are backwards incompatible to get around some of the design choices we made as part of libcnb v1, especially the idea of the layer contributor, and replacing that with something that allows you to dynamically generate labels, bill of materials, and other things. So let me just get those back up. Although they're merged in alpha v2 branch, that's not yet being released. So this was the list of core requirements for libcnb v2. This does not include the utility stuff that I'll be covering later, but this is currently the functionality that libcnb provides. I think the major changes we have made in v2 is renaming POET from POET to logs. This is simply to make it easy to understand what it's actually doing. And the other thing we've done is change how the layer contributor API works. So currently layer contributor was a function you had to return back, which libcnb called. This changes it to a normal layer object, which is what the contributor returned in the first place, and using that to create the output layers. There's this pull request that adds a bit more detail on how you can migrate from the current layer contributor to this new format, and why this new format is more powerful than what the layer contributor exposed. This is still in version 2.0, which is an alpha branch. We've not yet released it, but we're still looking for feedback on whether this is something that's useful, whether there are restrictions you hit because of the layer contributor concept, and if there is a better design than what we currently have in our alpha branch that you'd like to propose.
Couple of other things. We did pull out the old bomb entities or bomb entries.
Yeah.
That was deprecated and then removed. and we added all the new source bomb stuff. And then there's also a few things that I still want to clean up. There's some logic that we have in there that's handling older versions of the build pack API. I think we can probably remove that too. So we'll just support the latest one, whatever we release v2.
Are there like I'm just curious to know how like Rob, could you we've already walked through like how Packet and libpack want to use libcnb, but I'd be curious to hear your opinion on how Google plans on using libcnb, or if they have any opinions on the v2 design. I can't hear you.
Hi, can you hear me?
Yep.
Okay, that was weird. It just wasn't working. Yeah, what I was gonna say is I think I'm too new to the project. I've only been on the project like 3 weeks, so I'm too new to the opinion. I get what did you mean by how does Google intend to use libcnb? Does Google intend to keep using it? Was that the question?
Yeah, and like we know that like you currently wraps libcnb.
Yes.
And like I was just wondering if there's anything we can do on our side to like I know there's a bunch of things across various like these utility libraries that we've implemented in common. So like handling layer life cycle, profiling, timing, file IO management, checksum calculation. So things like this, I know that we've implemented across Packet, libpack, and the GCP build pack library. Are there any tools that you would have wanted the core or the utilities extension of libcnb to provide? And will any of the changes that we were talking about impact how Google is using libcnb? Or
Yeah, I mean, I think the list you have makes sense, and we would probably want to drop our stuff in lieu of that if made available. So, but yeah, I'm not super familiar yet with everything, and don't have a ton of opinion yet.
Yeah, I mean, I'll add the link to this document. So if you have some comments or something, you can leave it later asynchronously. I'll also add a link to all the pull requests and the plan changes we have for v2. So in case there's anything that's like that is making things harder for you, or if there are any features that would make things easier for you, please let us know. I think the other thing I wanted to ask was like the original reason we got in touch in the first place. And we are also trying to collect feedback on the SBOM feature. I don't know if you've had a chance to look at what like the implementation or like how you would implement it in Google build packs, and if you have any feedback on how the BAT team could provide better utilities to generate those SBOMs in the first place.
Yeah, so Google, wants to support software bill of materials with all builds. Google is still trying to figure out how they want to do that. Do they want to do like container scan of the file system, or do we want to take what the language toolkit gives us? Maven will Maven dependency plugin prints out whatever, plug that in there. Maybe a combination of the two. I'm not sure. I I haven't looked too much at what's available with build packs, but my impression is it's just kind of like a very like skeleton format. Like it's like a kind of a layout potentially, but not much beyond that. Is that right?
Yep. Currently, we just allow you to output the bill of materials in those formats, but how you generate them or how you put them in the first place is entirely up to you. The other thing is that we currently the API exposes an SBOM file per layer or one by the entire build pack for the application in form of a launch SBOM or a build SBOM. So these are all individual files that are not yet merged together into a complete bill of materials for the image. They describe the specific layer or parts of the application that the build pack is concerned with. So I'm also not sure if like there were any requirements on your side around that, or if you have any thoughts on that.
Not yet. It does seem to make sense that we would. I mean, the merging functionality seems like it'd be really useful. So, but no opinions yet.
All right. Is there anything else we want to talk about libcnb v2? I know that in the last party meeting, Frankie had some questions about v2 that she was going to regroup with the other utility maintainers about. I don't know if there was any update on that, or if Forrest has any updates on like the packet experimental version that uses libcnb v2.
I personally don't have that much context about that, and I don't see Forrest in the meeting anymore at this time.
Oh, okay.
So maybe punt to next week.
Yep. Ryan, do you have any points to add on V2? I know you've contributed a bunch of things.
I think there's maybe in my mind just some like open questions about some of there's like some printing functions, like almost every type provides some sort of print function off of it. I think it's for like debugging purposes. I guess my question was like, those necessary in the API? Are people using those? Are those load bearing APIs, or would people be upset if they disappeared?
Are there any examples, like any specific examples?
I think I was just looking at the Golang package documentation. I think it's like pretty obvious from that point when you just kind of like scan through the index of the docs. Yeah, back up by the index. It's like the listing at the top.
This?
Yeah, so there's a bunch of them that just have string functions hung off them. So bindings have a string, application path formatter has a string. And I don't think in any case they're like any sort of like structured output. So it's not like machine parsable or anything. They're like human readable strings. So my only assumption there is it must be for like some sort of debugging or logging purposes, but I just was like trying to clarify like why are these here? What do they do?
I think all these stringer interfaces are for like when we fail to parse bindings or something and we like output debug logs saying that, hey, this is the list of bindings we found, or or something went wrong. So I think we just mainly use it for debugging in our logs, like where we just pass the object and it prints out the string. I don't think we do anything else apart from that for it. I think the only other one where we might use the string stuff is the SBOM format one, where I think, does it do anything useful? Or is that also just for logging? Yeah, I think that might Daniel, do you remember if we use string anywhere?
What's the code for that one look like?
I think it was layer. String. Yeah, I think it's just. Layer go. Yeah, I think we use it. This is the only one we use, I think. Where
Yeah, I think that one is
apart from
part
that,
of the conversion and like parsing of those.
All right, that's fair. I think the other ones I saw were just like, they appeared to be some sort of like thing you could call if you wanted to output some debug thing in some sort of parsable format. And I kind of just was wondering, like, I couldn't figure out if they were like actually used internally in the code in any way, or if they were like meant entirely as like external facing APIs for folks to.
I think it's mostly just following the stringer interface so that you can pass it to logs directly. You can pass the object directly and it will print it.
Okay.
But is there
folks love that? Like, is that a thing that people are in love with, or? I don't know. I've just never seen an API that does that. So I'm just kind of like.
I mean, I think the only reason it might be useful is like if you're taking these objects directly and you want some human readable string in the logs as opposed to constructing it on your own. Is the only reason why we expose that stringer interface, but I don't have a strong opinion on it. Is there any reason why like you want to like remove them, or do you have an alternative implementation that you'd like?
I don't think it's a strong reason. It's mostly just like a desire for like a small focused API that doesn't have like extra stuff that it maybe doesn't need.
Yeah, I think the reason also is because it's like loggers do expect a stringer interface and it's hard to implement it once you're outside the package. So you'll have to, if you're for whatever reason taking this and printing it in logs anywhere, you'll have to redefine the type and add the string function yourself if you want to technically print it, which is why we added it. But again, there's no strong opinion on whether they should stay or not.
I mean, I use the debug output reasonably often, but I don't really care too much how that gets written. If it's using this and is necessary, then I would say it's important. But if there's other ways to write the same debug output, I wouldn't be opposed to removing it.
All right. I'm just trying to understand. For me, like if I was interacting with these types, I would just like use a format string and pull the fields I wanted to actually get information from, like more manually. Just kind of how I think about doing this type of thing versus relying on, you know, something that's come from a library or redefining the stringer interface, unless I was like strictly required of some like library I was passing this thing into. But it sounds like there's at least some plausible concern about this as a useful utility. So I'm not going to propose we do anything with it.
I think we've talked about a bunch in the past for having like all of these things output structured logs, but then it's also like that has always ended up in a larger conversation whether the project as a whole should have some structured logging conventions defined.
The only other thing I would say is the Paketo team's been working on a alternative SBOM implementation. We've got like an open PR that we've been having a conversation around. Our idea generally has been to leverage SIFT, like the scanning tool, to generate SBOMs. I can drop the PR we have open in the chat here, but what we have landed on as an API is not really what's shown in the top, but more what's shown later in comments towards the bottom. The major, I think the major difference between what's available in libcnb and what is proposed here is we're providing like a little bit more first class support for basically handing the API back what the SBOMs end up being. So we ask for like, instead of just saying like, here's where an SBOM could be possibly written, do what you will and write one there. We do a little bit more of the like handling of that. So we just ask for like an SBOM pairing where we basically say like, give us an extension and a reader and we'll handle like writing it to the proper locations on the file system for you.
Interesting.
And then that's in addition to, there's like another library we're introducing that actually does all of this SIFT stuff. So like using SIFT to generate your SBOMs, that part is like in a separate package that's entirely optional. But the top level packet API now includes this kind of like file extension reader mapping. That way, like you're not manually having to write files yourself to the right locations on disk. Instead, you're just handing them to Packet, who will then make sure that the stuff gets written in the right locations.
I think the reason we went for just providing the file path is that people can sometimes call binaries to generate the SBOMs as opposed to a library. And these binaries typically take the output path as a variable on a command line flag, I mean. And I guess we didn't want users to capture the standard out from these tools into a reader interface and then give it back to us. And if they wanted, they could implement an interface on top of libcnb that does implement that reader writer interface that you'd like with what we currently provide. So I think that's why we left it at just providing the paths as opposed to writing it out on disk.
That's fair. I'm not suggesting that libpack or libcnb change, just that just bringing it up as an alternative implementation that folks might get some ideas from.
Would you, is there anything that in libcnb that would stop you from writing this sort of an interface from what we already provide? Like if we give you the file path, can you wrap it up in this interface that you have so that the packet provides an interface to take in a reader and it writes it out to that path?
I mean, I think there is to a certain extent, right? We'd have to do things that I don't think are the right ways to go about doing them. Like we'd have to wrap the libcnb layer in a thing that is capable of taking this alternative API. Because like the way we're delegating the write is like through the type itself. Alternatively, like we just do this at a different point in time, but the way packets layer stuff is structured is like you basically hand back a Go type object that has all of the metadata about the layer, and then Packet is the one responsible for like writing that stuff out in the right formats that comply with the spec. And that is kind of broken if half the metadata gets written by the library, but this like other piece of metadata is written by a build pack itself.
Yeah, that makes sense. Do you also handle profile D right now? And
we don't, but like, given the experience on this, we maybe want to think about providing some more first-class APIs for that. As far as like thinking about having a file written somewhere, there's no reason we couldn't change the API to be like a read closer API, in which case, if you have something written to a file, you just immediately turn around and open the file and pass the file descriptor directly to the API. Say, here's where this thing is. It is maybe somewhat clunky, but at least provides a more fluent API, one that's not just copy this thing into a buffer or something.
yeah, I think it's also a tough situation for us because like so for profile D, libcnb, I think currently does allow you to just pass a string and we'll write it for you. I'll confirm that. But for the main issue we have is with execd, which is like we just provide a path where your execd binary can be, and you have to put it there. I think with SBOM we went sort of a similar route because the API does not define the keys, or it's not like a DOML specification defined by the project, as opposed like this is just the API saying that these files can exist. We don't define what's in the files. So libcnb typically has written files where the project owns the specification, like in terms of what goes in the contents of those files, and like we've just provided file paths for things that are outside of a specification, what you may generate in different ways. If that makes sense.
Yeah, I mean, I think we're doing the same, right? We're really all we're asking for is like the file extension bit, and we're doing the part that the spec does specify, which is like the file has to start with the prefix layer name dot sbom dot, and then you give us the file extension. And then the contents, again, is just like, it's a reader. You can put whatever you want in there.
Yeah. Yep.
Yeah, I think the reason we maybe haven't done very much on the profile D side is I think we have one build pack that is a non-Java build pack that leverages profile D, or maybe two. So we just don't have a ton of need for there to be like a nice API around the profile D stuff.
I think we are also nearing the end of our meeting. Is there anything else we want to talk about on V2? If not, I think we can give people 9 minutes back.